Okay, I want to introduce you to a three-dimensional rectangular coordinate system. And before I do that, I want to make some points about our usual two-dimensional system. So this is our two-dimensional rectangular coordinate system. This is the positive x-axis, this is the positive y-axis. So typically the labels tell us the positive direction of the axes. It's two-dimensional because you have the x dimension and the y dimension, and it's rectangular because this angle here is a right angle. Okay, this has other names as well. Sometimes it's called two-space for two dimensions. It's also sometimes called R2. This R represents the real numbers, and the squared means two dimensions. You have an R dimension on the x-axis, you have times an R dimension on the y-axis, so R squared or R2. So, when we look at the three-dimensional system, it will be similar. We'll have three space or R3 or R cubed, whatever you want to call it. Also, you can think of R squared as being like an ordered pair, where the first coordinate is a real number, and the second coordinate is also a real number. So you have two R coordinates. So all of those things are similar to one another and relate. Now, we already mentioned that the labels here indicate the positive direction, so we could clearly plot a point in this system. Let's say in this system I want to plot the ordered pair 2, negative 5. Okay? The way to do that would be to locate 2 in the x direction, which is horizontal. So in this case, x is the left, right dimension, and y is the up, down dimension. Okay? So this is x, this is y. X means go 2, positive 2 in the left-right direction. So in the positive direction, that's where the x is. So I'll go 2 in that direction. And negative 5 means go in the negative direction on the y, 5 units. And really what happens is you sort of make a grid when you do this, and the point is at the intersection of that grid. So this point is located there. Okay, I don't mean to drag out the two-dimensional space. I just want to emphasize some things that will help us when we get to the three-dimensional space. So now what we're going to do, and remember the angles here in the middle are right angles at the origin. We're going to sort of take this and put it in three dimensions and lay it on the ground. Okay? So when we do that, it's going to look something like this. The angle in the middle is still a right angle, but if I were to draw it, I would draw it like this. You see how this line here is parallel to this axis and the other line's parallel to the other axis. And now we'll call this x and this y. That's usually the convention there. Let me erase this now. So I'm simply taking this. Now this is my positive x direction and this is my positive y direction. Still two-dimensional, still right angle, the exact same coordinate system. Okay, so where would 2, negative 5 be in this coordinate system when we change the perspective of it? So I still go positive 2 in the x direction. My tick marks now are parallel to the y-axis, you see? Just like over here, my tick marks were parallel to the y-axis. And then I go negative 5 on the y-axis, so that's this way, and my tick marks are parallel to the x-axis. And I do the same thing, I make a grid, and I keep my grid parallel to my axes, and my point 2, negative 5 is now there. Okay? So that's the idea of taking the two-dimensional plane and putting it in three dimensions, laying it flat. Alright, so here's what we're going to do. We're now going to take this and add a third dimension to it. And that dimension will be the up and down dimension. So it will look something like this. I'll draw the up part of it first. And this axis we will call the z-axis. So this is the positive z-axis. The negative z-axis you could think of as going down. Okay? So in this case, the x coordinate is the forward or backward measurement. The y coordinate is the left-right measurement. And the z coordinate is the up-down measurement. Okay? Now, this could get really confusing really fast with all these lines. So typically what we do is we only draw in the lines that are positive. So I'll get rid of these negative axes. And then sometimes when you draw them in, you use dashed lines to indicate the negative directions if you'd like. Okay? We'll sort of leave those off though, just to keep our picture clean. Now, this idea of leaving off the negative directions is actually pretty common with the XY too. How many graphs have you seen that only have this, only the first quadrant? Quite a bit, I bet. That's because you only indicate the positives, and that's analogous to what we're doing over here, okay? Now, how do you plot points in this coordinate system? It's a little bit harder than it is over here, especially to visualize. The problem is, when we draw this, we're drawing on two-dimensional surface, right? A flat surface. And we're trying to represent 3 dimensions on this flat surface, so it can be difficult to visualize. But we'll do our best here. What's going to be useful to us is, just like in 2 dimensions, the grid is useful. Over here, we'll use something like a grid as well, but it will often be a box because we now have a 3rd dimension to this rectangle. We'll have a vertical dimension to it. So let's take a look at this. Now, points in 3 dimensions are not called ordered pairs. An ordered pair implies 2 coordinates, and in 3 dimensions you have 3 coordinates. So this is an ordered, it's still ordered, you still have x, y, z, it's in that order. It's an ordered triple, okay? So this is x, y, z. So the first coordinate tells you forward, backward. The second coordinate tells you left or right, and the third coordinate tells you up or down. So let's say we want to plot the ordered triple 0, -2, 0. So this means I'm not going to go left or right. Here's my origin. I'm going to stay here. I'm not going to go left or right. The -2 means go left 2. And the 0 means I'm not going to go up or down. So I'm going to go left 2 units. 1, 2, and there's my point. 2 units to the left, period. That's it. Very simple, right? This point right here. Well, okay, that's no problem. So that was because both of these are zeros. So let's change one of those zeros now. Let's change the first 0 to a 5, which means we're going to go forward 5. Because this is our forward or backward dimension. So I need to go forward 5. So 1, 2, 3, 4, 5. And then I need to go left 2 from there. So 1, 2. And here's our point. I'll sort of do this with a grid though. I went forward 5, left 2, here's my point, and then I'll go ahead and finish my rectangle all the way back to the origin. And that gives me a good idea of where this point is in this 3-dimensional system. Okay, so I went forward 5, left 2, and I didn't go up or down, so I stayed right there. That's why I only have a rectangle. All right, now let's change this last 0 to something else like -8, and that of course means go down 8, because z tells us up or down. So it's going to be very similar. I'm going to go forward 5. I'm going to go left 2. So let me label this as 2 now. This right here is 5. And I'm going to go down 8. Let me create some more room here. So from here, 1, 2, 3, 4, 5, 6, 7, 8. Now I'm going to get a box out of this. So you see this 2 left and this 8 down. I'm going to use that to create a rectangle. And then I've got my 5 dimension here. So I'm going to go back 5 up here just like this and over 2. And then I'll go 8 down one more time, something like this, just to get an idea. And I can do the same thing inside. Now where's the point? The point is the ordered triple, this point here. I go back and I say, okay, I went forward 5, left 2, down 8. The point's right here. So the box helps give you some perspective. It's left, it's down, and it's forward. That's where this point is from the origin. I know that is sort of difficult to see here because I'm drawing it in 2 dimensions, and granted, my picture is not great, but hopefully you can see. You go 2 left, this dimension back here is also 2, this dimension here is 5, just like this one is, and all of the vertical dimensions are 8. Each of these is 8 units. This is 2, just like the other horizontals, and this is 5, just like the other front to back. Okay? And then you plot your point at the correct corner of the box.